Hello dear students of third prep science. Let's go to start the first episode in this term as we talk about the physics, especially in unit 1, unit 2. Firstly, welcome back, and we will explain first lesson as motion in one direction. We know what is meant by motion. Motion, which means change your position from one place to another. But here we have to remember we have an important factor here in anything in physics as we talk about time. So if we want to talk about motion, we talk about position and time. Especially here we talk about motion in one direction, in straight line. Because in first prep and in second prep we studied before different types of motion, as a circular motion, as a vibrational motion. But in this year, especially in this unit, unit 1, we will talk about the motion in one direction. As we see here in the monitor, motion in one direction. First lesson, lesson 1, motion in one direction. Okay, what is meant by motion? Change of the object's position as time passes. As we see here in this image, the runners change their positions as time passes. We have here the stopwatch here, the timer. So they change their position as time passes. Okay, factors affecting motion. Factors affecting motion. We have two main factors affecting motion. Factor number 1 is position. Factor number 2 is time. Because if you have motion for any object, you have changing in the object's position, and at the same time passes, or in 1 second. So we have two factors affecting the motion. As we see the subway or metro underground, this metro moves in the simplest type of motion is the motion in what line, in what direction, as this metro. So is the motion in a straight line in one direction. So now we know the simplest type or form of motion, straight line in one direction. Okay. At the same time here, give reason for movement of metro or train considered as example of motion in one direction. Why we considered the motion of metro or train considered as example, clear example for motion in one direction here? So because they move forward or backward only, not upward or downward. So now we know how can we answer this question, because we know train motion in straight line in one direction. But why motion in one direction? Because metro or train move forward or backward only. Okay. Speed, and its symbol is V. V, speed. Speed, as we see here, these racers in this speed covered a distance, and at the same time we have time passes, or 1 second, or units of time. So speed, as we see here, distance covered as time passes, or in 1 second. So we have magic triangle to calculate speed. Speed, which means V symbol, equal distance over time. Here we have distance D and time T as the symbols. So V equal D over T. As we see, distance covered as time passes, or time unit, or 1 second. Okay. Factors affecting speed. As we see in the definition, speed is the distance covered as time passes. So the two factors affecting speed is number 1, the distance, number 2, distance covered, number 2, time. Because if we have no distance, we have no speed. Because if distance equals 0, the speed equals 0. 0 over any time as time 3 seconds or 4 seconds, 0 over 4 equals 0. Okay, dear students, we will take a little break, then we will return back again. Hello, welcome back, dear students. Let's go to complete our lesson today as we talk about motion, especially motion in one direction, and we know motion is change in position as time passes. So we have two factors for motion: change position as at the same time we have time as 1 second or time unit. The next point here is the motion in a straight line in one direction as simplest type of motion or simplest form of motion. We have a clear or more popular example here is metro or train. Metro or train considered as motion in one direction or motion in straight line in one direction. Why? Because it moves forward or backward only. The next point in our lesson is speed, and speed is distance covered as time passes or at time unit or in 1 second. So we have distance and time as the two factors affecting the speed. Okay, as we see here, we have distance covered as time passes or in 1 second. So V, this speed, equal distance over time. Factors affecting speed, distance and time. Here we have V equal D over T, distance over time. So the relation here between speed and distance are directly proportional. So by increasing the speed, the distance covered increases. If the speed increase, the distance increase. So they are directly proportional. Otherwise, speed and time are inversely proportional. Speed and time, which means by increasing the speed, the time decreases, and vice versa, which means by decreasing the speed, the time increases. So we know the relation between speed and distance as directly proportional relation, and speed with time as inversely proportional relation. Measuring unit of distance is, in our syllabus, meter or kilometer. No centimeter. We will use meter or kilometer only. As we see here, we have a distance between two persons. Here we have distance, and 1 kilometer equal 1000 meter. And we know the measuring unit here is kilometer or meter, and 1 kilometer equal 1000 meter. Measuring unit of time is, we have two measuring units, hour or second, not minutes. In our syllabus, we will use hour or second. And as we see here, pause or we will complete the time. So we know 1 hour equal 3600 seconds. Why? Why? Because each hour contains 60 minutes and each minute contains 60 seconds. So we have 60 times 60 equal 3600 as measuring unit of time. Okay, if we want to convert from kilometer per hour, the measuring unit of speed, to meter per second as another measuring unit of speed, how can we convert? We just multiply the number with 5/18. We take a number in kilometer per hour and multiply with 5/18 to convert into meter per second. As example, 100 kilometer per hour equal how many meter per second? If we want to convert it into meter per second, as we see here, 100 times 5/18 equal 27.7. So now we convert from kilometer per hour into meter per second. Another convert from meter per second into kilometer per hour. We, yes, divide over 5/18. So from kilometer per hour to meter per second, we multiply with 5/18. But from meter per second to kilometer per hour, we divide 5/18. As we see here, example, 40 meter per second equal how many kilometer per hour? So 40 divide 5/18 equal 143.9. 143.9 kilometer per hour. So now we can deal with how can we convert kilometer per hour into meter per second and meter per second into kilometer per hour. Okay. As we see here, we have the device. This device is called speedometer. It's called speedometer. Device used to identify the speed of cars, planes, many طبعا of cars, planes, any machine as boat or and so on. So speedometer used to identify the speed of car directly. طبعا we have many types of speedometer, but the main job here to identify speed directly. Problem. Here we have a car covers 60 meters through 2 seconds. Calculate its speed. We want to calculate speed from the magic triangle. We know speed V equal D over T, distance over time. So we have V equal 60 over 2. So the speed equal 30. But 30 watts? Yes, 30 meter per second, because the measuring unit here of distance is meter and the measuring unit of time is second. So the measuring unit of speed in this problem is meter per second. The types of speed. The types of speed. We have two types of speed. We have uniform or regular speed or constant speed. Speed doesn't change. Object moves with constant speed, which means uniform or regular speed, which means the speed doesn't change. For example, this object moves with speed 70 km per hour and doesn't change. So in this case, this speed is called constant speed or uniform speed. And another type of speed is called non-uniform speed or irregular speed. Not constant speed, not constant, changeable. So Body covered equal distances at equal periods of time or time interval. Body covered equal distances at equal periods of time. So here we talk about uniform or regular speed or constant speed. Another type is non-uniform or irregular speed, which means body covered unequal distances at equal periods of time, or vice versa. Why vice versa? Because here we can use equal instead of unequal, and here we will use time as unequal instead of equal. So we can use or can say equal or unequal distances at equal periods of time and vice versa. Okay. Next, give reason for. Give reason for. It's hard to measure a regular or uniform speed practically. من الصعب إننا to measure regular or uniform speed practically. Because on the surface of the earth or in the atmosphere of the earth, we have many objects move at the same time. So practically it's hard to move with uniform or regular or constant speed. For example, for cars. Cars can't move in the streets with regular or uniform speed continuously. So the answer here, due to traffic motion. Due to traffic motion. It is hard to measure a regular or uniform speed practically due to traffic motion. What is meant by? What is meant by? We talk about regular or uniform speed. An object moves with uniform speed equal 70 meter per second. An object moves with uniform speed equal 70 meter per second. Here we have to answer by the definition of uniform speed, but we will use the number. How come? Object covered equal distances, and distances here equal 70 meter. At equal periods of time equal 1 second. So if we talk about any definition, we will use the definition, but we will use at the same time the number. The measuring unit of distance here in this example is meter, and the measuring unit of time is second. So the object covered equal distances equal 70 meter at equal periods of time equal 1 second. Average speed. If the object moves with non-uniform speed, which means unequal distances at equal periods of time or vice versa, we use average speed to know how can we calculate the speed of irregular motion or irregular speed of any object. Okay. V dash. The symbol is V dash. Total distance covered over total time taken. So in average speed we sum or take the summation of all distances covered and divide them over total or the summation of time taken to calculate the average speed. For example, what is meant by car moves with average speed equal 120 kilometer per hour. So we talk about the definition of average speed. So total distance covered over total time taken equal 120 kilometer per hour. So now we can use the numbers inside the definitions. The last point in our syllabus today is relative speed. Relative speed, which means what? Speed of an object relative to another or the observer. So we calculate the speed of an object but not its real speed. Not its real speed. We will calculate the speed of an object relative to another object. The other object here is called observer. Is called observer. So it depends on the position of the observer. Number one, if the two objects moving in the opposite directions, like this, car move in direction and the other cars move in the opposite direction. So in this case, how can we calculate the relative speed? Relative speed of any object to another, here we calculate VA plus VB. VA, which means the first car, and VB, which means the second car or the second object. In this case, relative speed of any object to another. VA plus VB. We summation of both speeds. But if the two objects move in the same direction, as you see here, the two cars move in the same direction, here we have relative speed of any object to another is VA minus VB, minus not plus, if the two objects move in the same direction. For example here, the problem زي ما انتم شايفين, two cars, car A 60 km per hour, car B 35 km per hour in the same direction. في السؤال قدامنا بيقول in the same direction. Calculate relative speed of car A relative to car B. يبقى VA minus VB, يبقى 60 minus 35 equal 25 kilometer per hour. Okay, by the end of this example, we end this episode. Until we meet again, thank you, see you, and goodbye.